Today's topic is going to be graphing cube functions and cube root functions. And happy June 1st, everyone. Your note packet should have 4 pages. You don't need a ruler for this. We're going to be sketching smooth curves. So let's start with the parent function of a cube function. So the parent function, remember, is the simplest function of this style. You'll notice that the exponent is to the 3rd power, and there are no other terms with that x to the 3rd power. In the graph, you can see that it's approaching negative infinity on the y-axis, as well as positive infinity on the y-axis as well. But as this graph continues to grow on the x-axis, it's going to expand, and it's going to approach negative and positive infinity as well. All cube functions have the same basic shape. So they should look like, I don't want to call it an S, but it's kind of going up like this. Now a cube function also has an inverse function, and that's going to be the cube root function. And this is the parent function for the cube root. Again, you can see it's very simple. It's the cube root of x, but we have an index of 3. And the shape has taken our basic parent function from a cube function, and it's basically turned it sideways. So this is the basic shape that you'll see with all cube root functions. On the iPad, you're going to want to use this function right here, x, and it's raised to some kind of power. They're using a little box. That means that when you activate it, you can type in 3 for the 3rd power, or whatever power that you need to. And then we're also going to use the function underneath it, which is going to allow us to use a cube root function. But again, you could change the index to anything you want. That's part of the problem. So in example number 1, when I see this, I see x to the 3rd power. I should immediately be able to tell that that is a cube function. And we're going to graph this first. I'm going to use the iPad, and my graph has that basic shape that we talked about on the last slide. I'm also going to have to graph this by hand. So I'm going to pull up a table from my iPad. It's going to provide lots of whole number values and integers. Obviously, we cannot graph all of these, but you're going to graph as many as you can fit on your own graph. But again, you should already have that idea of the basic shape. So you'll go ahead and sketch that smooth curve based on the points that you've plotted. From here now, we want to identify the domain. So the domain is your x-axis. And again, even though we're seeing it run between, looks like -2 to around +2 or +3, as this goes and approaches infinity, it's going to get larger, so it's going to spread out horizontally. So our domain is from -infinity to +infinity. It'll be the same with the range, and we have arrows on our graph. And now they want to know, how does this graph compare to the parent function? Notice this is not simply x to the 3rd, but they're also adding +2. So you can see the original graph did cross at the origin, and now we have moved up 2 units. So the +2 is outside the function, and that's indicating a movement vertically. So the function moved up 2 units. We've modified the function a little bit in example 2. It's a little more complex, but we have something occurring inside the function and then something occurring outside the function. So let's go ahead and graph that first. On my iPad, I should already be able to recognize that basic shape. And this is the table that's associated with this particular graph. And again, only graph the points that you can fit. Typically, there's 4 or 5, but when you go to sketch it, make sure you put arrows on it, you label it, and give it that basic shape. We're going to identify the domain and range, and I think you'll probably get the hang of this right away, but the domain, as we go from -infinity to +infinity, our graph is going to expand. And same with our range. We're running from -infinity to +infinity. And then how does this graph compare to the parent function? Well, we've moved away from the origin. both vertically and horizontally. So we've got a movement 2 units to the right. Remember, inside the function, x lies to you. So the negative looks like it's going to the left, but it's really going to the right. And then outside the function, this is accurate. +1 means we move up 1. In example number 3, this looks a little bit different. We have 3 terms, but the cube term is actually negative. So when I go to graph this, instead of it having its basic shape where it starts on the left-hand side of the y-axis and kind of moves to the right, it's actually the opposite. So again, there's my table. We'll graph the points that are graphable. And the iPad graph is a nice visual so that you know that it looks like it's been flipped over. So the domain is going from negative to positive infinity. Same with the range. And then how does this compare to the parent function? The first thing that I notice is I have -2 in the function, so that tells me that it has moved down 2 units. But the other thing that I notice is the first term is negative. That is now going to be classified as a reflection. We flipped it over the y-axis. So it's facing the opposite direction that we're used to. Now, in example number 4, instead of using a cube function, we're going to use a cube root. So we're going to start by plugging this into our iPad. Make sure once you put in the square root of x, you use an arrow to the right so that you can get out from underneath that square root, and then type in -3. So remember, cube root functions also have a basic shape. We've taken our cube function and we've turned it. Here's the table. Now I've actually had to include 2 sections of the table. Usually when you graph this, we're graphing 4 to 5 points. 3 of them are typically all right in a row. This is where we're going to get that turning, but we need one that's on the far left and we need one here that's on the far right so that we get, I call this one an S. So the domain and range, even though that this has been tilted, and we can see that the domain is traveling from -infinity to positive infinity, the range will do the same because as it moves left and right, it will also expand vertically up and down. So our range is negative to positive infinity as well. How does this one compare to the parent function? The parent function always passes through the origin. Ours no longer does, but you can see in the function we had -3. That's outside the function, and that tells me that it moved down 3 units. In example 5, we have another cube root, but we have +1 underneath the square root. That's considered inside the function. So let's go ahead and plug this into our iPad and get a graph. It should have that basic S shape. So the domain is going to move from -infinity to positive infinity. And again, in my table, I can see the 3 points that are right in a row. I have one that's beyond that to the right. I don't have one in my table that's beyond that to the left, but you can use your table and you can find that point yourself. All right, domain, negative to positive infinity, same with the range. So what we're seeing here is that all cube functions and cube root functions have domains and ranges that are from negative to positive infinity. So how does this graph compare to the parent? Well, clearly it's not going through the origin. We can see that we have moved 1 unit left based on what I'm seeing up here in the function. So the +1 tells me 1 unit to the left. And finally, number 6. We're going to go ahead and put that into our iPad and graph it. Even though 5 has been listed first, you could technically move it after the square root and do +5, and it serves the same purpose. So that is your movement vertically. So my graph has that S shape. It looks like it's moved left and up. Here's the table associated with that. The 3 points that are right in a row. We do see one at the top of the graph or the table here, -10, 3, And then we also have 6, 7. So you do want to try to graph 5 of these points. Make sure you put arrows on it and a label. And from our last 5 examples, we know domain and range are both negative to positive infinity. And then how does this graph compare to the parent? Based on what I see in the function, I've moved 2 units left and 5 units up. This will be homework number 123. You'll see the top of it will say cube roots and graphing cube functions. If you have any questions on this assignment or as you go through the homework or the notes, please make sure you get in contact with me. Otherwise, have a great day.